Welcome back to our PCG tutorial series. In this episode, we're going to use PCG to add books to our bookshelf. So we have variation between our bookshelves, and we'll also set up spawning of blueprints from our room graph so that we can add those PCG modified shelves as well as active elements like this candle. So let's get started. One thing I thought it would be nice to do in the last episode is to add books to this shelf. This one's nice being full, however, when you use multiples of them, they're all the same, which is very obvious when you use a bunch of them. So if we could create a bookshelf that has a random arrangement of books using these books or other books that you have, then that would be more interesting when we use multiple of them. And PCG does have this capability. In order to do this, we need to activate a different plugin. We need the PCG Content Generation Framework Geometry Script Interop. Activate this plugin here, and then you'll need to restart your editor. So what we want to do here is sample the shelves so that we can put points onto the shelves of this static mesh. In order to do that, we need a PCG graph inside this bookshelf. So currently this bookshelf is just a static mesh. So what we're going to want to do is add a blueprint for this. So we just need a blueprint actor class, call that BP bookshelf. And then we'll open up BP bookshelf and we'll add a PCG graph. And then we'll need to add the actual graph here, which we don't have yet. So let's go back to our content browser and add a PCG graph. And we'll call that PCG bookshelf. And we'll add that in here. While we're in BP bookshelf, let's also add a static mesh. And if we just drag this up to the default scene root, it will replace that and become the scene root. And then we can set this to bookshelf. Compile and save that, and then if we drag that in, we see we have our static mesh, which is good. Then we want to go into our PCG bookshelf, and what we want to use is a mesh sampler. So the mesh sampler will trace the shape of our mesh and allow us to put points onto it. For our mesh sampler to work, we need to give it the static mesh. Select the static mesh again here. So this is a copy of the static mesh, not the actual static mesh that we just set up in our blueprint. So for this static mesh to be at the correct location, we need to set that location. To do that, we'll use copy points. And we'll take this sample of points here as our source, and our target we want to be the location of our blueprint version of this mesh. We're going to use getActorData, and with getActorData we can get a single point of self, and that's going to be our target. Now this set of points from the mesh sampler gets copied to the location of our blueprint actor that this PCG is part of. If we click on our mesh sampler and we click A to inspect the output, and we make sure we have our bookshelf selected up here, we can see these points that are generated, and there's a lot of them. We see the position here is the sample points position. If we look at the copy points position, this is our position of our actual actor. You can see those points have moved over. So if we now go into debug, and instead of using the PCG cube, it's going to be easier to use this tripod, I think, to see our points. And let's do an absolute of a 0.1 maybe, and take a look at those points. These are the points that we are finding on the bookshelf. So what this is doing is it's generating a point for every triangle in this static mesh. And you can see around the drawers here, this is generating a lot of points that we don't need. And on the shelves are very simple. We're not getting enough points on the shelves to spawn our books. Now we're going to need to filter these points and get just the top of the shelves, get rid of the things like this arc up here that we're not going to need to put in books, and increase these so we have enough for the books. So if you click back to the mesh sampler, we have this sampling method, 1 point per triangle. That's where these points are coming from. And we have a couple of other sampling methods, 1 point per vertex, which looks like this, which is not more to our liking. And then we have Poisson sampling, which is interesting, but I don't think that's going to help us either. I think the default method is fine, the 1 point per triangle. So what we can do is add a normal to density. We debug that instead of this. We leave this scale method on extents and the PCG cube selected for our debug, and we look at this, we'll see that the points which are on the top are white, and the ones that are on the front of surfaces are black. And that's because our normal vector is pointing up, and so that's going to give us these points that are on the shelves, which are the ones we want, and it's going to get rid of these ones that are on the front and the back. So it'll give us more of the points we want. There's still some we're going to have to get rid of, but it's closer to what we want. So normal to density. If we wanted, for example, these front points instead, we could change what this normal is. This normal right here is pointing up. So if you wanted to have a different result, you could change that. Now you can see it's getting the front points are white. What we're going to do is we're going to filter this with a density filter. We set this filter to 0.9 and we debug this instead, and we're going to see now we only have those front points because I changed that vector. But if we go back to our normal to density and we change this back to our upwards point, now we see just these points on the shelf and a couple points here that are on the tops of things, which is closer to what we're looking for. So then to filter out the points for just these shelves, I'm going to use a bounds modifier off this original point. And if we turn the debugging on, and let's set this to some values from 1 to 50, so we can see that. We want to use set, not scale. And then we can see that this cube is coming off this pivot point right here. If we scale that so that it covers the shelves, then we can intersect those and we can get rid of these points that are outside of the shelves. So we extend this up, start this at 50, and then we go up to 150. How does that look? Better, but not quite. Take that 250. There we go. 220 worked well. And then we just need to get this width correct. And our depth is not correct either. Let's make this minus 20 and 20. And then for our width, there we go. That's close. We're not far enough down on the bottom, so let's fix that. And I'm not coming out quite to the end of the shelves, so let's fix that as well. So make this 25. This we wanted to change. So that looks about right. So if we then take this bounds and our points here, and then what we want is an intersection. We hook those both up, and then if we debug this output, we'll see what we get out. And that looks like more what we want. We got rid of all those points on the outside here. We got rid of the points that were on the handles and the bottom here. We just have those shelf points. We got rid of the ones on the top as well. So that's perfect. And now we just need to get enough points in here to spawn our books. Then we want to make these points more the size of our books. So we'll again use a bounds modifier. I'm going to set again, and then let's go. And then if we filter these, we'll use self-pruning. Let's just do a quick test here and spawn in some books. So we are getting 2 points this direction, but if we switch our bounds modifier so that's facing the correct direction here, that's going to get rid of those. These books that are meshing into the shelves, we can get rid of those too by modifying this a little bit. We just make this a little skinnier. There we go. The books are obviously facing the wrong direction. We need to transform points for that. So in our transform points, we can put in a 180 rotation. Get them facing the correct direction. So now we still have an issue with not enough books, obviously. I think the best way that we can get more points across these shelves and get them in the correct place is by creating a points grid. So let's create points grid. And for the points grid, we want a cell size and an extent. And then we can copy that onto the existing points here. So let's add a copy points. So the points grid is our source, and we're copying that onto our target, which is our existing points. And let's take a look at what that gives us by default. Nothing. Okay. So let's look at what we're getting here. Oh, right. So for our points grid, we want to make sure to uncheck this cull points outside of volume because we're not using a volume. So now we're creating a points grid and that should be copied onto our target points. And we have lots of books. Okay, that's great. So now we just need to get our size correct. So our cell size is way too big. We don't need 100 by 100 by 100. What we want is more like 10 by 10 by 1. So now our books are much closer together. And our extent is way too big. Okay. We just need to dial this in. Our shelf's only about 20 deep, 40 there. That's getting closer. So if we look back at what we're copying from here, for now, let's deactivate that. We have these two sets of points. So we're getting a front and a back set of points. We just really want one of those. Actually, we could deal with just 1 point per shelf. So maybe let's try and reduce this to 1 point per shelf. Instead of this bounds being the size of our books, let's make the bounds the size of our shelf. Let's turn the debugging off on these guys. And let's look at the debugging on this. And let's deactivate the book for now. So right now, this is trying to be the size of the book. So let's make that more the width of our shelf. Now we'll use this self-pruning and take a look at that. And then we have a single point. We can get this dialed in a little bit better on the size of our shelf. But in truth, it doesn't matter. What we really want is just 1 point there. But just for the sake of it, let's make this a little closer to our shelf size. So here with 0 to 40, minus 50 to 90, and 0 to 5, we have a point that roughly spans our shelf. Then if we take this point and we use that as our target here, let's re-enable this, and then we'll take this point out to here, get rid of this line, move this copy points over here. Now we should be creating a grid across our shelf. Okay, and that grid is too far forward on these shelves. It's perfect on the bottom one. That point that was on the bottom was further back. So we can adjust our settings here, increase this extent to 80. 5. Let's make this more like 60. This 5 with giving us a single point is good here this way. Now our points are all shoved over to this side. We can adjust that as well. So let's put a transform points in here. We can use this transform points to move things over. Try 20 here. Yeah, okay, that's centered. Let's push these back with that transform as well. Okay, that's good for these top ones. This bottom one is out the back now. That's not great. That's a little far back. I think we kind of want the center of the shelves. Let's go with 20. So if we want variance in where the books sit on the shelves, you need to do that after the points grid. So it'd be this one you want to modify if you want to vary that. Let's say we want it to vary where they sit on the shelves. Then we need to debug after this. And then that'll give us some variance in their depth. We really need to deal with these points being further back on the shelf than these points. So let's take a step back. Let's look at this self-pruning node. So what we're doing here is we're taking these points here. Let's go back and look at those. Turn these points off. We'll look at these intersection points. These are the points we're starting from. Then we make those bigger so they overlap with each other, and then we prune them with this self-pruning node. So instead of doing self-pruning, if we take these points here, we can see that they stick out here. Since we want 1 point, we could take this point here that doesn't stick out. So if we take this intersection again, copy that, and we put that down here. We take this bounds as our source again. We take this output point here, and we do another intersection. What we end up with, if we debug this instead of this, as you can see, these have gone gray, and that's because this has been applied to density. So if we look at the output here and we look at density, you can see a density has been applied to all of those based on this intersection. These darker ones are lower values. Those are the ones that are sticking out more. So if we get rid of all those lower values and we keep these white ones, we'll have a consistent result. So we apply a density filter here. And this density filter we want to set to 0.8. So if we look at this value here, we see these 0.8s are our high values. 0.804. So we apply a 0.8, and then let's look at the output from this density filter instead of this. Now we can see we have just these white results left, and there are just 4 points now. And those 4 points are all at the same depth on the shelf. So now we don't need this self-pruning. We can run this into our target. We'll turn these debugs off, turn debug back on here, and now we have a consistent position on all those shelves. And all we have to do is move that back again, which was this transform points. Oh, that changes our density factor when I move that back. So let's change our density filter to be 0.5. And now we have a consistent spot on those shelves. Now if I turn this back on, we see a nice consistent placement of our books. And there is a little variance, which is from this transform points, that we can control here and control, do we want those books all at the same depth or do we want them varying? We have a nice consistent set of where we want to put our books. Now let's play around with this and make this look more organic. First, we can add all the books to this static mesh spawner. So this static mesh spawner can support an array of different elements to spawn in. So we can just add those all in here. And if you didn't import those all during the last episode, I'll have a link in the description for you for these. Alright, so there we go, 13 different books. I'm going to also add an empty book there as well. That way we can potentially have some gaps. And you can adjust the weight of any of these as well. It's similar to the weight we set up last time. So if we say this gap has a weight of 3, it's going to be more likely to have gaps than any of the other books. So then I'm just going to mess with the spacing a little bit, reduce our cell size here in our create points grid. Our books will be a little more close together. We've got some overlap here in these fatter books, so that's a little too skinny. Probably if we have all these books be the same size, it'd be easier. I'm gonna go with 7 for now. So then I'm just gonna pull in a second bookshelf and you can see how those books look different. So you can also play with the angle in this transform points if you want to. You wanna play with the X. Getting that looking natural might be difficult, but we can use these PCG parameters to give more variance to our books. And you could put items in here other than books as well if you wanted to put a candle on the shelf or other items that might be knickknacks, whatnot, that might be on a bookshelf. Make things look even more natural. It'd be a good idea. You could also play with the spacing. If you wanted to create books that are lying down or pages or things like that, you could put those in as well, playing with the spacing. This just to give you a general idea of how to set this up so you can get started. And then from here, it's just kind of tweaking things to make it really how you want. And you can take this same idea and apply it to things like this weapon rack here. Spawn in weapons leading into this rack. I was thinking that'd be another good use, or across the rack this way. You could also do tables. So a plain table like this is, well, obviously plain, but you could use this technique to get the top surface of this and then spawn in the goblet, the plate, some silverware, you know, some of these other knickknacks onto that and make it more interesting. Similar to how this desk is set up with all this stuff on it. If we had this desk as a plain object, we could spawn in a variety of different things. Then each time this desk spawns in, it would be different. And it's a great use of PCG. So in order to get our blueprint actor outputting here instead of these static meshes, there's a few things we need to change. First, let's go into our PCG blueprint room props. We'll go into our point loop body, and here we need to add a couple of attributes. Like we added mesh here before. So what we want to do is go back here to the beginning. We'll make some more room here. And we'll add 2 new attributes. We want to create a Boolean. Grab this. Create Boolean attribute. And we want to create a string attribute. And we want to hook these up here. And our Boolean attribute is going to be is BP actor, and our string attribute will be BP actor. And then at the end, we're going to set those. Let's make a little more room here as well. And we want to set Boolean. And that's going to need our point and our metadata. And that's going to be our is BP actor. And we're going to set that to true if we have this element prop type here. We're going to get a copy of that and we'll pull that down here. And we want equals enum. If this is a blueprint, then that's going to be true. And we'll set that. And then we'll also set our string attribute. We don't have our parameter to set that to yet, but we can get this set up. This is going to be BP actor, and we want to hook these up. Then we want to go into our S room data. We want to add a variable. We're going to call that BP actor. And then we want to select actor, and we want a class reference. Then we can go over to DT rooms, and we can switch our prop type to blueprint. And then here we want to get our BP bookshelf. And then we have the reference to that set in our data table. Now we can go back into our PCG blueprint room props. Now we can set this value here. So we'll go over to PCG room and go into our next to the wall section. We'll start there. We want to do this for all the sections just so we have the option of doing blueprints, but we'll do it here first. We want to split these output points into which ones are static meshes and which ones are actors. So we're going to use a spawn actor here. In order to split those out, what we want to use is a point filter. And in our point filter over here, we're going to set up, we want equals, our target attribute is BP actor. We want to use a constant threshold. We want this to be a Boolean. Our Boolean value is false. So if it's false, we're going to use the inside filter. We're going to go to the static mesh spawner. If it's true, then we'll go to our spawn actor. Then in our spawn actor, we need to set this up. We want to use no merging for our blueprint actors, and then we want to spawn based on an attribute, and our attribute is our BP actor. Then let's check our data here from our point filter. Make sure we have a room selected. We need a room selected with bookshelves. This is not showing any bookshelves here. Oh, I'm looking at the inside filter. I want the input. Okay, so this is separating correctly. So we have is BP actor. We've got true and false here. And then if we look at our inside filter, we see our falses are going to our inside filter for our static meshes. And then our outside filter, our trues, are going to our spawn actor. But we can see our BP actor has no value. So let's go back over here to our room props and see what's going on here. So to debug this, I'm going to set a breakpoint here on this set string attribute. And then we'll compile this. And we should be able to look at this value. There's no value. There's no class reference. Oh, but we've got a ton of data to go through here to find the correct element. Okay, so to debug this, I added a branch here so that on the true value, we go to this set string attribute. That way we're testing if this value is true. This is just temporary in order to break on this only when we're in blueprint mode. And I see that no value is set here. And the reason for this is because right here when we're setting this array element, I forgot to hook up the blueprint actor. So we need to hook that up as well. Otherwise, we're basically unsetting this value. Now that we have that set, we should see out here in this data, oh, we need an outside filter. There it is. So now it's coming through. If we look at our BP actor here, we can see this is the name of the actor. And what we actually want is the soft object path. So when I pulled this in here, it defaulted to get class display name. There's a different function here we want, get soft class path. And then if we right click on this, we can split this pin and it's going to turn into a string. And we have that as a string. File and save this. And then if we look at our outside filter, now we have the BP actor path, and that should be what this spawn actor wants. There we go. And now we have our bookshelves coming in here. And we can see that the arrangement of books is different. Now we can play around a bit with this and get this looking a little more organic. They all look like they're leaning a bit to the left. Not really what I want. If we go back in here to PCG bookshelf, we can mess around with our transform points and set our rotation here -5 to 5. That way some of them are kind of tilting to the left, some are tilting to the right. I think for now that's going to be acceptable for me. What I want to do next is also turn this candle into a candle with flame. I have a short where I create a blueprint actor torch. I'm going to use the same method here to add a flame to this candle and then turn that candle into a blueprint actor in our data table. Also, I want to do this point filter down here as well. Just copy that down and copy down this spawn actor. Now our on the wall points are set up for blueprints, and then let's do that same thing here. Copy both of these and go over here to our centers and paste those and hook that in here. That way both of these are set up for blueprints as well. Once that candle's set up, and I will provide a link to that short that I did on setting up a lantern, head over to your DT rooms, find the candle, and I'm just doing the wall candle, and we want to change that to blueprint type and set that blueprint candle. Do that for both copies of this. Force regen. And now we have a working light, and it didn't like me hitting play on that because I don't have a valid player character in here. But if we eject and get over here to see this candle, we can see we have a nice flame going and it's producing light. So that's working correctly in locations where I have that spawning in. Now that we have this working, we can use this technique to create variation in our other props. If you need any help doing that, please join our growing Discord community. If you've enjoyed this content, please like it and remember to subscribe for future content. If you're able to support the channel, then please join my Patreon. All the links are in the description. Thanks, and I'll see you in the next video.